Hey Chem Kids, this is Underwood coming at you with another webcast. Today we're going to be talking about percent yield and percent error. Before you continue with this video, I urge you to go back and watch the limiting reactant video that I just posted on Moodle. These two videos actually coincide with each other, and you're actually going to have to show us these three skills: calculating the limiting reactant, calculating the percent yield, and calculating the percent error. These are all things you're going to need to know how to do. So it's good for you to see how it all fits together. When we get into the idea of percent yield, you're going to encounter a couple terms. First one is theoretical yield, and that's the amount of product created when the reaction actually runs in ideal conditions. So it's like that runs perfectly, and we all know that experiments never run perfectly, really, but the theoretical yield is actually the thing that we calculate in our gram-to-gram conversion bridges. So if you remember the last problem in the limiting reactant video, you calculated two amounts of water being produced from two gram-to-gram conversion bridges. 0.70 grams of water was our final limited production, and that right there would be our theoretical yield because we calculated that. Our actual yield is the amount of product created when you actually carry out the reaction in real life. So if I was to take the products stated in a problem and put them together in a reaction and get something in real life, then that actual yield was the amount of product that I actually got. So when we're talking about percent yield, we're actually asking the question, what percentage of the theoretical amount was I able to obtain in a real-life experiment as compared to the theoretical yield which I was able to calculate? That's probably a little confusing at this point, but we'll go ahead and rock through an example here, and I think it'll make more sense. When you're calculating percent yield, the equation that you're going to use is this one right here. You have the actual value, and remember the actual value is the one that you actually obtained in the experiment. And then here's the theoretical value, and the theoretical value again is the one that we calculate using our gram-to-gram bridges in our limiting reactant problems. So we take those things, we take the actual value, we divide it by the theoretical value, and we multiply that all by 100, and when we do this, we get the percent yield. Okay? Awesome. So if we were to take our problem from last time, you'll remember, or you should remember, that that we actually ended up saying that we can make 0.70 grams of H2O. That's what we calculated in our limiting reactant problem. All right, and since we calculated it, that's our theoretical value. It was calculated. It's theoretical. Theoretical. And again, 0.70 grams of H2O. Now, if I read further, it says you are able to capture 0.62 grams of water when you carry out this experiment in the lab. Calculate your percent yield. Well, remember, the actual yield is the amount that I obtained when I actually did the reaction. So this little sentence here tells us that we got 0.62 grams. So 0.62 grams of H2O would be our actual it would be our actual value. So if you recall, the equation for calculating percent yield was the actual divided by the theoretical and we take that and we multiply it by 100. Now this is going to look like this when we put it all together. The actual 0.62 grams of H2O divided by 0.70 grams of H2O. Okay, take that, we multiply it by 100. When I put that in my calculator, I end up with 88.6% yield. So that means, what that means is that when I actually carried out my experiment, I was able to obtain 88.6% of the calculated theoretical value. So that was actually pretty close. 88.6, awesome. But what if we decide to go a step further. What if we wanted to know just exactly how close we really got? We wanted to compare the situation. We could then go on and add this question. Calculate the percent error. Now this is a new thing, and the new thing we're going to encounter. Alright, so we'll talk about that a little bit. Percent error is calculated when scientists want to compare the percentage difference between two quantities. That's probably a super complicated definition for you, probably pretty hard to understand. So let's go through and let's just go do a calculation, and I'll show you, and it'll probably explain a little bit more about what percent error actually is. So when you're calculating percent error, the equation is just a little bit different than the percent yield equation. Here you have your actual again, and remember the actual is what you were able to obtain in the actual experiment. The theoretical value is here. Remember, that's the one that we calculated from our gram-to-gram conversion bridges. And then theoretical here again, we use that value twice. So we've got the actual amount minus the theoretical amount, and then divided by the theoretical amount once again, multiply that by 100, and that's going to be our percent error. So let's go ahead and work on an example together. So here's our problem once again, and remember, if you were to go back and recall, we were able to obtain 0.70 grams of water from our limiting reactant video, that example that I put up there. All right, and once again, we were able to get 0.62 grams of water in our experiment, the one that we actually carried out. And so if we want to write down our variables, we have our theoretical value, and that is 0.70 grams of H2O. And then we have our actual value, and that is 0.62 grams of H2O. So there are the values that we need. Remember the theoretical, the one I calculated, the actual, the one I actually obtained when I did the experiment. And then if we recall, the equation for percent error is the actual value minus the theoretical value. Okay, we take that value and we divide it all by the theoretical value again. Okay, and so we times that by 100 and we'll get our percentage. As I continue to go, this goes ahead and translates. The actual, again, is 0.62 grams of H2O. We're going to subtract that, or sorry, we're going to subtract 0.70 grams, our theoretical value. We're going to go ahead and divide, once again, by the theoretical value, which in this case, again, is 0.70 grams of H2O. Take that value, we multiply it by 100, and when I put that in my calculator, I find out that I had a percent error of negative 11.4% error. Okay, and so we were able to see, obviously, if we got 0% error, that would be perfection, right? We did awesome. And in this case, we were about 11% in error away from getting the theoretical value, getting the perfect answer. Notice here that it is negative. You can have a negative or positive percent error, so you need to make sure that the right sign is associated with whether or not you got less in your actual value than the theoretical value, or you got more in your actual value than the theoretical value, and then that'll determine whether it's a negative percent error or a positive percent error. Really pretty simple problems to calculate. Again, if you have any questions, please don't hesitate to ask. Come in, get some extra help. We can get you squared away and understand these concepts pretty well. For the time being, this is Underwood signing off.